All right. Well, we could all say hi to Micah because he's going to be the one listening to this video, and I just told him the backstory.
Hi, Micah.
Hello.
With two people.
Got him.
V, do you want to say something? All right, so let's get rolling here.
Question, would it be okay if I turn off those lights up there because it's just reflect?
Oh, I thought they already were off. Hit the third button down.
I think this one just got brighter.
Well, yeah,
More power.
This side
Yeah.
was kind
Is that good?
of half off.
You can come sit right up here in the front row, right here.
But like I said, I see all the backlights in here.
No, you can turn off all the lights as far as I'm concerned. I don't care. I can see fine. Okay. So we talked last time that Scheme, well, I assume everybody has ordered the book, right?
I have it already.
Yeah, you have it already? Oh, good.
I
Good.
definitely ordered.
All right, so make sure you order the book. Yeah.
Right here. PDF.
Okay, so because I'm going to start giving you homework assignments out of the book shortly, probably even today. All right, so we talked last time about this programming language Scheme, which is a functional language, and the reason we use it in here is because it's a very minimalistic language. That way we don't get overburdened with a high-level general purpose, object-oriented, or even procedural language because we're going to be creating our own languages in here. But leading up to that, we need to become skilled at using Scheme. And as I mentioned last time, loops don't exist in Scheme, and even though there is a special function that has been written that will allow you to pull it off, you're not allowed to use it. So you have to accomplish everything recursively. And I promise you that'll make more sense when we get to it. And it'll actually make your life easier because interpreters, in many cases, are written in terms of recursive sets of data. All right, so we'll get back to that. But as starters, I mentioned that Scheme is a list-based language. Oh, good. Apology not accepted.
I'm curious that why are we using Scheme instead of Lisp?
Well, Scheme is a superset of Lisp.
Okay.
They're the cars, cooters, this thing we're going to talk about today works in Lisp.
Okay.
Yeah, so maybe let's just say that the book adopts Scheme as its core language, and everything we're going to do in here, you could do in Lisp.
Okay.
Yeah, we're not using any special Scheme things other than Dr. Racket gives you a nice little environment to write the stuff in. You know, Scheme is a superset, so there's some other magical, amazing things in there. We're not going to use them.
All right.
So get used to when you need a helper function, you're going to write a helper function. All right, so when you think about learning programming, and it's like, oh, well, you need to do something, you might need to do it 2, 3, 4, 5 times, and it's not built into the language, or you're not aware that it's built into the language. You just go and write a quick function that does it. We're going to be writing lots of helper functions in here to do different things. Okay, so we have this idea of a list, and just to reiterate in Scheme. Let's call it, so Scheme is a functional language. So let's say Scheme function calls. So the syntax for Scheme would be function, it's called function name, and then space param1, space param2, space ... param n. I kind of recall already writing that on another slide, but it's fine. It's important. So we'll rewrite it here. Okay, so if I have a list like this, the very first element of that list is expected to be the name of a function. All right, and what Scheme will do is it will Scheme attempts to what it calls apply. I'm just kind of using some book verbiage because the book does read a little bit like stereo instructions. Scheme attempts to apply function name to the collection of parameters. All right, that's what scheme tries to do. If you're creating your own list in that you don't want scheme to try to apply function name to the collection of parameters, if you don't want this default behavior, you must use a single quote prior to the list. That tells it, don't execute this as a function. Treat this as a list that I'm making. Make sense? All right. So again, scheme's a pretty simple language. That the slide right here is a core tenet of scheme that you will want to remember because it will cause you nightmares when things don't work or do work but do the wrong thing. Something like that, like you happen to have the first element of your list happen to match up to a function call that you happen to not know it existed. And because scheme is a superset of Lisp, so there are some things built into it, and I might disqualify some other ones as we go on, but I'm officially disqualifying anything that allows you to make loops. So everybody heard it here? If you find something in scheme that lets you do loops, you're not allowed to use it.
Does that include go-to statements?
There is no go-to statement, so let's say yes.
Okay.
Yeah, it wouldn't make sense in a functional language anyways, but sure. One of my goals in here is to really get you thinking recursively. Because typically for programming students, when you get to a course like this, the average student is not comfortable with recursion. Recursion is a tough thing to wrap your mind around. It's, think about merge sort with the 2 recursive calls. Even if you finally got it working or something like that, it was still just this vague, weird thing. If you already feel confident with recursion and things like that, you're going to adapt to this stuff pretty quickly. But I promise the rest of you will hate this at first and eventually will only be able to think recursively and you'll have trouble going back to iterative thinking. But you will be able to go back to iterative thinking and then you won't be afraid of recursion anymore. Okay, so today we're going to work with building and manipulating lists. All right. Oh, yeah, I basically had it in that first slide that I brought up, but it's important enough to have it on 2 slides, so we'll just keep it like that. All right, so 3 functions we're going to look at initially today, and then we might look at some more. So car is a function that takes a single list as a parameter and returns the first element of the list. For example, the car of the list 1, 2, 3 will produce a 1. Let me show you this to you in Dr. Racket. Do I not have it open? Oh, I think I have it down here. Nailed it. Please insert Dr. Racket floppy disk. Let's see, I need to...
What does CAR stand for?
That's a good question. I don't know what it stands for.
Okay.
Probably a guy's name or something like that.
Okay.
But while I'm checking, while I'm getting bigger text size here, somebody look that up and find out what it stands for. This is an interesting question. Font size. Yeah. Make it bigger up here? No. Make any sense.
Contents of the address.
The who?
Oh, contents of the address part of the register. So contents address register.
I don't think that's maybe do what does car mean in Lisp or something like that.
That's what I did.
Really?
Yeah.
Yeah, the Wikipedia page, car and cooter.
Yeah. What does CUTR stand for?
Contents of the decrement register.
So I'm guessing the car is.
Yeah, they must have just
something register.
they must have adapted it. I don't know. So let's just go back with my thing that
That's
says
a popular explanation, but does not quite match the IBM 704 architecture.
Thank you for that
There we
lovely
go.
explanation.
Apparently, if we just read a bit further.
I'll look for Dr. Becky.
That's the one.
where's my font size? General? Yeah, what I thought editing would be here. General editing. Maximum characters. Show line numbers. Line numbers might not be horrible. Oh, that's funny. It makes this thing giant. Well, maybe it is big. It just look. The little cursor was this tiny cursor. All right, shut up!
Whatever comes after.
I have solved the problem. All right. Here,
Oh my gosh.
just real quick. So I'm going to show you one other function real quick. That way we can use it. Where's my keynote? Oh, there it is. Here, we have the define function. Remember we talked about programming languages, how human beings solve problems? Memory, asking questions, repetition. How do we ask a question? Or how do we remember something in Scheme? How do we define a variable? We use define. So is a function that takes two parameters, a name and a value to pair it with. For instance, define A as the list 1, 2, 3. So you're going to get a lot of nested parentheses here. You're going to love parentheses when all of this is said and done. So if I come in here and I say, so up top here is kind of like you can always directly interact with the interpreter down here. So I can come down here and say define A to be the list 1, 2, 3. And then from that point forward, I can say A and it spits out the list. But that's a real-time thing. It says, warning, the definitions window has changed. Click run. If I click run here and then I type in A, it's not going to know what I'm talking about. Okay, so that's me kind of directly interacting with the interpreter, but no permanence to it. So usually when you're talking about writing your program, you're going to write it up top here, because this is code that you can then go and modify and make changes to. So I'll say define A to be the list 1, 2, 3. And then if I run that, that executes that stuff. So now if I type in A, it knows about that.
It's useful that you can kind
Yep.
of modify it directly through the interpreter then.
Yep. Well, yeah. Now you can modify it, but as soon as you hit run again, it just runs through the code that you have up here.
Oh, yeah.
Yeah. So I would say you test down here with the interpreter,
Yeah.
but you put code up here. So I've defined a variable, named A, set it equal to a list that I'm now going to use to show you how car works. All right. Now going back to this guy here, what does car do? It's a function that takes a single list as a parameter. So you must provide it a list. It operates on lists. And it returns the very first element of that list. So if I type in, open parenthesis, then the name of my function is car. And this guy takes a single parameter, takes in a list. Do I have a list? I do. It's in a variable called A. If I say, give me the car of A, it's going to give me the very first element of A, which is my 1. Make sense?
I have a question.
Sure.
What if they want to take 2 lists or something like that?
But this function doesn't take 2 lists. It takes 1 list.
Only one?
That's what this function does. If we want to put this in real life, what if your car wanted to have 2 keys?
No, I mean, like, what if you're, like, doing, like, you know, like different lists to like matching this and that, like compare what I'm.
I get it. That's not what this function does. Just like your car has a single keyhole, right? And you could say, well, what if I wanted to put 2 keys in there? Well, you need a second keyhole. That's a different kind of car, probably something made in,
Nuclear stuff.
I don't know. I'm thinking maybe like a Vietnamese vehicle. How many keys do they take? Well, now we have to share with Micah now that V is from Vietnam, so that's why we say that. We have a person from across the pond. We have to explain this to. He's going to have to be able to testify with human resources at some point. All right. Pay attention to me.
You just broke his headphones.
Micah's eardrums are just destroyed.
Or be smart as looking on 2x speed and he didn't even notice.
It's okay, this is what car does. Car is going to return the first element on the list. Okay, so that's what car does. It gives you the very first element of a list, and the car function takes exactly one input. It takes a list. Have to give it a list. So if I say, give me the car of B, I don't have a variable named B. That is the literal string B. It's going to scream at me and say, hey, car expects a pair. Expects a list. We have this thing in Scheme called dot notation, dotted pairs. So it works a little bit different than a list, but let's just focus on lists for right now. That's what it expects, that kind of thing. All right, so if I give it the wrong input, it's going to scream at me. All right, questions about what car does? All right, good. Coder. A function, keynote, cannot connect to the cloud. Is Falcon, Falcon that down? Oh. Yeah, whatever. It'll save later. Okay, I'm on now. Save.
Welcome to computer science.
All right. Mike is changing majors. All right, so coder is a function that takes a single list as a parameter and returns everything except the first element as a list. So we can say coder gives you the rest of the list. So for example, the coder of the list 1, 2, 3 will produce for us the list 2, 3.
That's a weird function.
Oh, yeah. You're going to be using that a lot. Cars and cooters are going to haunt your dreams. All right. So, if I say cooter of A, where A is the list 1, 2, 3, it gives me the rest of that list 2, 3. Go ahead.
So would that remove?
Doesn't remove. A is still 1, 2, 3. I haven't changed the variable. I could say define B to be the cooter of A. And now I'll have, it won't remove it from A, but now I have another variable called B that's equal to the cooter of A.
Oh,
2, 3.
I can see how that could be useful now.
Is it only, like, does B only exist in this current context? Or, like, if you were to use B again, would it still be equal to? Yeah, okay.
Until you.
It's a variable.
Okay.
The same thing as me saying B is equal to, we're doing a little mixing, matching stuff, the coulter of A. Define is how we define variables.
Okay.
Yep. And one thing you'll see is we will not actually be using define to define variables with normal values like you're used to. We're going to be using define to define functions. Lambda expressions
Yeah.
that Luke asked about last time. Okay? And everybody understands lambda calculus, right? That we just don't have to cover that?
Oh, yeah, absolutely.
I dreamt about it last night.
Go ahead.
Like that. Do they have anything to define like objects in this one?
Sort of. But maybe we can go with the pace I want to. Because I tell you, I promise this is going to get real hard if you're trying to solve all the world's problems day one. And they do, but we will actually not be using object-oriented aspects of Scheme, because why would we when we can just write our own object-oriented language
All right.
and then use the object-oriented aspects of that? Makes more sense, doesn't it?
Yes.
Yeah, I mean, why use a pre-built? If we wanted an object-oriented language, we'd just use Java. No, we're going to use Scheme. Well, if we want objects, we'll make objects. It's like my language now needs to support objects. Our language needs to support variables first. We're not even close to having a variable environment in our language. Okay? We got lists, we got define, we got cars and cooters. All right, so remember back to like we talked about, what does a CPU do? You know, all these little magic tricks. I say, anybody, you know, like this, anybody impressed if I do that? Nobody's impressed if I do that. Nobody's impressed if I do that. But if I do these movements all in a row, I can accomplish something real. You got cars and cooters and defines and some of these other things, conses, all put together in a very specific order. Some really cool stuff happens. Go ahead.
Do you want to tell our Ann Arbor friend what you were doing?
No.
Okay.
Why don't you describe it to him?
All right. Professor or Dr. Lippman was moving his fingers in motions to demonstrate simple movement.
Things are so much clearer for him now.
He wiggled his finger.
I was wiggling my fingers. I said, nothing's impressive about an individual wiggle. But if you move all the right fingers in the right little motions, you can pick up your coffee mug and drink coffee. That's what a CPU does. It does little tiny little tricks, and you put enough of them together, real things happen. Go ahead.
So what type of variables that they have, in Scheme?
Lists and string literals and numbers.
So then are they having floats and integers and like that?
That doesn't exist.
Right now, you have ints, you have string literals, and you have lists. That's what your world consists of right now. Right? We solve all problems in terms of the toolbox we have in front of us.
Mhm.
Now, would we all agree if you had more tools now, I could give you harder problems now?
Perhaps.
So we probably want to limit our tools for a little bit. Because I promise you, this language, this is gonna be a nightmare for you. Okay? But when you come out the other end, you're gonna be like, oh, programming makes so much more sense now. I promise you. All right. So, car gives us the first element as an element. Now, what does that mean? That means if I had something like define B,
Wait, how do you get the numbers again?
the who?
The numbers,
It's
the
a-
line numbers.
All right, one of the property things when I was looking for.
It's in view.
All right, so if I say define B to be a list containing the list 2, 3, 4, list 5, 6. So this guy right here is a list containing 3 elements. The first element is a 2 list with 2 and 3 in it. The second element is an interliteral, 4. The third element is a 2 list, 5 and 6. So what is the car of B? The list 2, 3. That is the first element of that. what is the car of the car of B?
Literal
Just
two.
2, 3, or yeah, 2.
Yep. So I'll take the car of B, which will give me the list 2, 3. Then I'll take the car of that, which will give me the value 2. Now, the cool kids, I would do it this way for a while until you start getting a little braver. And you've attained the ability to pronounce some of these other functions. The car of B.
Wait.
That's the car of the car.
Wait. So you just add as many A's as you want to work with?
It's not as many as you want. It's up to, there is a limit. Something like 8 or 9 or 10, something like that.
Oh my gosh.
Okay. Now, I could say I want the cooter of the car of B. What will that give me? Yeah. 3. Just 3?
List 3.
The list of 3. Did you know that, or you tested it already and saw it?
I'd already just ran that.
Oh, so tell me why it's the list 3.
Well, because you haven't actually gotten the literal 3 yet. You're getting the first element of B, which is the list 2, 3, and then you're getting the list of everything but the first element, which is a list containing 3. So a list that just doesn't contain 2.
Okay.
So you haven't actually gotten the 3 out of that list yet.
All right. That's true. Also, cooter always returns a list. That's what cooter returns. It returns a list. Could be an empty list, but it does return a list.
So cooter and car both return this, or just cooter?
Just gonna.
Car returns an element,
Gotcha.
which might be a literal, might be a list, might be something else, could be a function, all sorts of stuff. So car of the cooter, I'm sorry, the cooter of the car will give me the first element of my list B, which is the list 2, 3. Then the cooter of that will give me the list 3. The car of the cooter of the car of B will give me the 3.
Or the Kadar of B.
Or the Kadar of B.
I see.
So now I'm curious, what does the C actually mean if it's not a keyword? It's like this C-A-R-C-E-R.
Good.
So then basically you're saying that the cooter always return a list?
Yes.
The cooter function, the result of the cooter function will always, 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 always be a list. It might be the empty list. So for instance, the cooter of the list 1,
Since whatever the end is.
what's the result of this going to be?
First element.
Is it no?
No, I know that.
It's either
Well, it's the empty list.
Just basically
Okay?
what the
So,
car is, yeah.
so cooter returns everything except the first element of the list as a list. Make sense? So there's the empty list.
Kadar. Cooter of the car.
So I have a question now.
And then
Will car return a list?
He just asked that question.
which is the first element.
Car returns the very first element of a list. Could be, it's a list here. The first element of this guy is a list. The first element of this guy is not a list. All right, everybody pay attention to me. Stop this extra crap talk. Okay? I know this better than you do. Promise. All right. So, what's the cooter of the empty list going to give me? What's the car of the empty list?
There's nothing there.
Yeah. Car only works on a list that has at least one element in it. If it doesn't have any elements, you can't get the stuff.
So can you have like a three element list that has 2 values and 1 empty, or no?
Well, you can have a list of 1, 2 empty list. But it doesn't work like an array. You can't have a 3 bucket list where the 3rd bucket has nothing in it.
Okay.
Yeah. This would be a 3 list with 3 elements. First element is a 1, second element is a 2, third element is the empty list. All right, so cars, cutters make sense. Now, what I'm telling you right now is you never, ever, 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 ever have to use any of those fancy cadadders and cars or cadars and all that stuff. If you don't want to, you never have to do that. Things will get a little bit more impressive looking with the parentheses, the more cars and cutters you physically put out there, but it's never wrong to do that. Okay, so until you get comfortable with the cars and cutters, I would strongly encourage you to just use cars and cutters and not any of these special little things. Right? Because they are going to be harder to debug. Eventually, what you're going to see is typically you won't go that deep into a list. You know, it'll be like the car of the cutter. That might be kind of a common-ish thing. But you will rarely have something like the car of the cutter of the car of the car of the car of the car of the cutter car. That would be an extremely specific problem you're solving. All right. But that would be kind of something that might show up on a quiz or something like that, where I gave you, here's a complexy looking list, decompose this, collection of cars and cutters.
Okay.
Make sense? I mean, I wouldn't give you like 50 of them, but I would not put on a quiz like the weird, CADDADDADR thing. Not that you shouldn't be able to do it, but it's unimportant. It's syntactic sugar, for a phrase that you've heard me say before. It's not part of the core scheme language. It is syntactic sugar to allow you to accomplish some common things in less verbiage. All right. So cars, cutters make sense. Define makes sense. Okay. Cons is a function that constructs a list. It takes 2 parameters, an element, which can be anything, could be a list, could be a string literal, could be an int literal. That's what we know about right now. So it takes an element and a list. The second parameter to cons must be a list. Go ahead.
So lists in this language are more like mathematical sets than an array, right?
That's what it looks like.
I guess it depends on what you mean. Depends how you use it. I mean, a list is going to function like an array would function if you're solving problems that just require a collection of stuff. Yeah, I don't know. I think probably overthinking it.
Okay.
Yeah, they're just collections.
Okay.
Mm-hmm.
Just want to make sure. So then you said an element and a list. That means, what if we take like a list and a list? Would that work? You said the second one must be a list, but then.
Oh, right. So you're saying, what if I try to construct the list 1 and the list 2, 3? Yep. So what this will do is this will take this element and create a list where this element is the first element of a new list with this being the rest of the list. So I've constructed a list. I took a list and I added something onto the front of that list. I added that element to the front of that list.
Can you flip it? Or no?
You flip what?
Like, can you put the 2, 3 in front of the 1? I'm assuming yes. But.
Well, you want it to be.
Is your second argument a list?
Yeah.
Then yes.
Yeah, okay.
I mean, you can do whatever you write the syntax to do.
I wasn't sure if it was like single elements only, if it's
No, I mean, this could be, you could say, I want to construct the list 1 onto the empty list, and that'll give you the list containing the list 1.
gotcha.
Now, one thing you might run into sometimes is cons 1, 2. Oh, they took the dot notation out. Good. You can't create pairs that way. I bet you actually can if I chose a different one of these languages up here. Remember earlier I mentioned that thing says it requires a pair.
Mm-hmm.
There's this thing that will end up looking like 1.2. Yeah, so it doesn't like pairs in this, which is good. We're not going to use them anyways. Okay. So that's what cons does. Cons constructs a list. Append. A function that takes an element and appends it to the, let's see, a function that takes 2 parameters. Let's keep an element and a list, and appends the element onto the front of the list. Let me show you the difference between append and cons. Just run this again real quick. All right, so if I say cons 1 onto the list 2, 3, what am I going to get?
List 1, then 2, 3.
Be a little more specific. What's the very first element of that list going to be? The list of 1, right?
Mm-hmm.
So this is going to construct a list whose first element is that list.
Mm-hmm.
And the rest of the list will be the contents of this list. So there's the list containing the list 1, followed by a 2, followed by a 3. As opposed to append 1, 2, 3, which will append this guy onto the front of this guy. It glues 2 lists together. But what if I did this? Append 1 onto the list 2, 3. So append is kind of like concatenation-ish. So this guy takes a list and a list and appends the 2 lists together. Into a single list. Now understand it does not flatten it though. So if I said append the list 1, list 2 onto the list 3, 4, I'm going to get a single list whose first element is 1, whose second element is the list 2, whose third element is 3, whose fourth element is 4. Oh, notice I double quoted this, so that quote thing in the middle here. The other one made sense too, but it wasn't the example I was trying to show you. It was actually the 3 lists because I had a list element called the quote. All right, so when I append this to list, which is a list containing the int literal 1 and the list 2, onto the list 3, 4, I get a single list as an output where the first element is the 1, the second element is the list 2, the third element is the 3, the fourth element is the 4. So it merges these lists together, concatenates these lists together. Make sense? That's what append does. All right, so that shows us some list manipulation stuff. What time's class over?
Yeah.
A minute ago? Okay, so I'm going to give you a reading assignment out of the book. I'll look it up here in a few minutes, and then I'll put it up on Slack because we won't have anything to turn in for it. But there's a pretty high risk of a quiz next class. We'll have to figure out how to do that for Micah, but we'll figure it out. All right, questions, comments, concerns, bribes. Yes, bribe?
No, just
Do
question.
you need extra crickets?
Is the quiz gonna just be on like the definitions of?
It's on anything we covered today. All right, I will see everybody on Friday.
Yeah.